Hi, welcome back to the fifth session in an introduction to programming for teachers in the Python programming language. Once again, I'm Luke. And in this session, we're going to be continuing from session 4 and continuing looking at our decisions, so the ways we make decisions using if statements. Okay, so the goals of these slides are to understand multi-way branching, to write statements using the Boolean data type. We might have looked at this data type before, but we're going to go into a bit more depth today. To slice strings, so to pull out a substring of a string, and then also to validate user input. Okay, and then in the little yellow box, we get, in this chapter, you will learn how to program simple and complex decisions. You will apply what you learned to the task of checking user input. Okay, so multiple alternatives. This is the idea of multi-branching. What if you have more than two branches? What happens if what you're considering isn't just if-else? There are actually lots of different things to consider. So let's look at this Richter scale and consider how many branches we're going to need, because we're going to need a branch for, if we've got our Richter scale, our value is greater than 8, or 8 or greater. We're going to need another kind of branch to consider what happens if it's between 7 and 7.99, right, for this many buildings destroyed section. What happens if it's between 6 and 7, right, many buildings considerably damaged, some collapse. What happens if it's between 4.5 and 6, and then what happens if it's less than 4.5, right? So we're going to have to use more than just one if-else. We're going to have to use quite a lot of different considerations, different branches. And then in the yellow box, we get this really, really useful hint of, when using multiple if statements, test general conditions after more specific conditions. Okay, so you want to be specific at first, and then slowly as you go through your if statements, you get less specific. Okay, you become more general. Okay, so let's look at this Richter scale as a flowchart. So we come in with our value on the Richter scale, and we test the most specific case first, which is if it's greater than or equal to 8. And if it's greater than or equal to 8, most structures fall. Else, if it's greater than or equal to 7, okay, but it's failed this greater than or equal to 8, so we know it's between 7 and 8. If that's true, many buildings are destroyed. If it's false, then we check if it's greater than or equal to 6. And this is going to give us a range between 6 and 7, or just less than 7. And then if that's true, we know that many buildings are going to be considerably damaged and some collapse. And if that's false, we need to check if it's greater than or equal to 4.5, which gives us another range of greater than or equal to 4.5, but just less than 6. And that can be true or false. And if it's false, then we know our Richter scale value is less than 4.5, strictly less than 4.5, and we can print out there isn't any destruction of buildings. Okay. So as a Python program, we have, if the value on the Richter scale is greater than or equal to 8.0, print most structures fall. Else, if we check if the Richter scale value is greater than or equal to 7.0, print many buildings destroyed. Else, if, and so on. Okay, so this is a Python implementation of this flowchart. What I might recommend you guys do is pause the video, copy this down, and test it for different values of Richter. So set your Richter value to something about 9.5. Set your Richter value to 7.5, 6.3, 5.2, and then something like 0. Okay, and see what happens. If you also want to test the useful information that was in that yellow box about being most specific and then becoming more general, try and switch maybe these two around. So have your if Richter is greater than or equal to 7.0 first, with its print many buildings destroyed. Else if the Richter is greater than or equal to 8.0, print most structures fall. And you should see that if you enter a value that's greater than 8, it's going to trigger the first greater than or equal to 7 condition, and then skip the greater than or equal to 8 condition. Okay, so you want to be most specific first, and then more general as you move down through your if statements. Then we have another Python program that you can copy down, so pause the video and copy this one down. You might notice that the first Python program uses ifs and else-ifs and else's. This one just uses if statements. Copy it down, think about whether or not there's going to be a problem with this code, and if there is going to be a problem with this code, try and work out what it is, and then test this program and see if your suspicions are confirmed. Okay, there is something wrong with this code, copy it down, enter in a Richter value of something like 9.2 and see what happens, and you should notice that there are some issues. And this leads us on nicely to Boolean variables. Okay, so we've mentioned different data types in other sessions. We might have even mentioned the Boolean data type in other sessions, but we're going to focus on it for a little bit here. So a Boolean variable is often called a flag because it can either be up, which is true, or down, which is false. Okay, so the Boolean value, or Boolean variable, a Boolean is a Python data type. It's a data type in Python. It can only have one of two values. It can either be true with a capital T, or it can be false with a capital F. Okay, and we can create a variable, something like failed, and make it a Boolean value or a Boolean data type by assigning it a value of true or false. Okay, so in this here, we've created a variable. It's the Boolean data type because it's storing a Boolean value which is true. Okay, Boolean variables have operators that work on them, and these operators are things like and or. There are also other ones like not. And what they allow us to do is they allow us to combine multiple conditions into one overall condition. And that lets us write some interesting code, which can be quite useful. So we can combine two conditions together to do something like range checking. And this is often a common use of using Boolean values and also the Boolean operators. Okay, so we're going to check whether or not a value is between two other values. And we're going to do that using an and. So if we look at this grey box, we say if the temperature is greater than 0 and the temperature is less than 100, print liquid. So they're telling us that the water is in its liquid state, for example. Okay. For this to print the liquid statement, both the temperature has to be greater than 0 and the temperature has to be less than 100. So both of these conditions need to be true. Okay? If our temperature is something like 62, 62 is greater than 0, so we get a true from this side. And 62 is less than 100, so we get a true from this side. We get true and true, which is true. Both are true. And we print the liquid line. If the temperature was something like 300, well, 300 is greater than 0, so we get a true, but 300 is not less than 100, so this gives us a false. This side gives us a false. This side gives us a true. True and false is false. We need both of the sides of the and to be true to get this print. Okay, and you could do the same thing by checking something that's like minus 20. Minus 20 is not less than 0, so we get a false from this side, but minus 20 is less than 100, so this gives us a true. So we have false and true. We need both sides of the and to be true to get a true out, so overall we get a false. Okay, and you can look at this table here, which gives an indication of that. So here is a flowchart of the and operator, of how it would work with our little Python program. So our Python program, if temperature is greater than 0 and temperature is less than 100, print liquid. So our temperature comes in. If it's greater than 0, we pass it on to the next if part, or the next condition, which is the temperature less than 100? If both of these are true, right, we follow down the arrow, we get water as a liquid. If either of these are false, we never hit this water as a liquid line, and we'll do something else. Okay, so this is often called range checking because we're checking or validating that some input, for example, in this case, the temperature, is between two values. It needs to be greater than 0 and less than 100. Another operator we use is the OR operator, and we use the OR operator if only one of two conditions needs to be true. So if we wanted to check if something wasn't a liquid, we could check whether or not its that, well, water isn't a liquid, whether or not its temperature is less than or equal to 0, because if it's less than or equal to 0, it's going to be in it as ice, so it's going to be a solid, or if the temperature is greater than or equal to 100, because if the temperature of water is greater than or equal to 100, it's going to turn into steam. Okay, and steam is a gas, ice is a solid, neither of those are liquids. Okay, so this gives the output of true. This OR operator gives true if either of the sides are true. Okay, and you can see that again in the table. So if A is true and B is true, A or B is true. If A is true and B is false, A or B is true. Okay, we just need one of the things to be true. So if both are false, the output is false. Okay, so for an example, if the temperature is minus 20, we get minus 20 is less than or equal to 0. Well, that's true. Or minus 20 is greater than or equal to 100. Well, this is false. So we get true or false. And if we go into the table, true or false is true. So it would print out not a liquid. And if water is at minus 20 degrees, then it's going to be a solid. It's going to be ice, which is not a liquid. Here's the flow chart of the OR operator. So again, we've got a Python program of if temp is less than or equal to 0 or temp is greater than or equal to 100, print not a liquid. We come in here, we check if the temperature is less than or equal to 0. If that's false, we still need to check if the temperature is greater than or equal to 100, because it might be not a solid, but it might be a gas. Okay, if either of these things are true, we jump to the water is not a liquid. We follow the arrows. If both of these are false, then we would move on with a separate section of our program. So this is another form of range checking. Whereas the AND operator was used to check if something was between two values, the OR operator can be used to check if something is outside two values. Okay, we're checking specifically that the temperature is not between 0 and 100. It's outside that range. Okay, and then we reach a third operator that works on Boolean values, which is very useful, called the NOT operator. The NOT operator is really useful if we need to invert a Boolean variable or a comparison. We precede the comparison with a NOT. So if we had a Boolean variable called attending, right? Maybe it's talking about a student attending the course. This can either be true or false. Either the student is attending, and the attending value is going to be true, or the student isn't attending, and the attending value is going to be false. If we wanted to negate the attending value, not attending would just flip the value held in attending. So if the student is attending is true, then not attending is not true, which gives false. If the student isn't attending, so attending is set to false, then not false or not attending is going to give us true. Okay, this negation and the idea of Boolean variables can be a little bit tricky. The more examples you see, the easier it becomes. So if we look at the Python program, we have if not attending or grade is less than 40. Okay, so if the student is attending, so attending is true, not attending gives false, and we only need to check whether or not their grade is less than 40. If their grade is less than 40, they're still going to be failing even though they're turning up to class. If they're not turning up to class, so attending is false, then not attending is going to be true, and they're going to be failing independent of what their grade actually is. Their grade could be greater than 40, and they'd still get the student failing printout. Okay, another way of checking things is maybe using the AND to check if they're actually doing okay. So if attending and not grade is less than 40, so if attending is true, they're turning up to classes, and their grade is, let's say 60, 60 is less than 40, well, this is going to give us a false, because 60 is greater than 40, but then we negate that false to get a true. So we've got the student is attending, which is true, and not 60 less than 40, which gives us a true. We're going to print out the student is doing okay. Now this line here can be quite confusing, and even working through it and reading it out is quite difficult. So sometimes you want to not use the not operator and instead try and use a simpler logic. So instead of having not grade less than 40, we could have grade greater than or equal to 40. Okay, and this is much easier. It's highlighting the wrong line, but this line here is much easier to read than this line here. It's much easier to understand what it's doing as well. Okay, A slightly different operator can be used rather than using the not operator when checking for inequality rather than negation. So instead of negating a Boolean operator, we can use an inequality check, which uses the exclamation mark. So we get a user to enter in a password, and we want to check whether or not the password they've entered is the password we have on file, right? Whether or not their login information is correct. So if the password they have entered is not the same as the file password, okay, this is what this exclamation mark equals is. That's equivalent to if, and then negating the value come out of user password is the same as file password. Okay, double equals for comparison. Okay, so not user password equals file password. Again, this version is probably easier to read than this version, even though they do the same thing. Okay, they are the same tests. Okay, so if you're comparing two things and you want to check if things are not the same rather than checking if they are the same, I would recommend using exclamation mark equals. Okay, so here's a table of Boolean operator examples that you can kind of read through and check, which I'm going to do now. So the expression we have 0 is less than 200 and 200 is less than 100. Well, that's going to give us false because 200 is not less than 100. Okay, so we get a true from this side. 0 is less than 200, so that's true. And 200 is less than 100, that's false. True and false is false. Okay, for an AND operator to give us a true output, we need both of the inputs to be true. Okay, so we get a false out. Only the first condition is met. In the second line of the table, we're using an OR operator. 0 is less than 200, that's true. Or 200 is less than 100, that's false. With the OR operator, we only need one of the conditions to be true for the result to be true. 0 is less than 200 is true, so we get true or false, which gives us true. Okay, the first condition here is true. 0 is less than 200 or 100 is less than 200. Well, both of these are true, so the output's going to be true. The OR operator is not a test of one of these things has to be true and the other one can't be, either or. If both the conditions are true, the result's going to be true. If we look at line 1, 2, 3, 4, we get 0, we have the expression 0 is less than x, and x is less than 100, or x is the same as minus 1. There is an order of precedence for Boolean operators. The AND operator has a higher precedence than the OR operator, so we evaluate this expression as 0 less than x and x less than 100, or x is the same as 1. X is the same as minus 1. Okay, so the brackets come in around the AND operator section, so 0 less than x and x less than 100, rather than being 0 less than x and x less than 100 or x is the same as minus 1. Okay, the brackets go here and here rather than here and here. Okay, because of the order of precedence of the operators. Okay, then we move on to the expression in line 5, not 0 less than 200. So 0 is less than 200, so this is going to give us a true, and then not true is false. Okay, and then the final two lines are talking about comparing values with Boolean variables with values like true and false. Frozen equals true, so comparing the value held in the variable frozen with the Boolean value true. Well, if frozen is true, true equals true is going to give true. And if frozen is false, false is the same as true is going to give us false. So what this evaluates to is just whatever value is already held in frozen. So there is actually no point in ever comparing a Boolean value or a Boolean variable with true. Just call the variable name instead. If the variable name was true, the output was going to be true. If the variable value was false, the output's going to be false. Okay, and then similarly, frozen equals false. Well, if frozen is true, true equals false is going to give us false. And if frozen is false, false equals false is going to give us true. So it just flips the value of frozen. If frozen was true, frozen equals false gives us false. If frozen was false, we get true out when we compare it to false. So we might as well just negate the value held in the variable frozen instead of doing a comparison with false. Okay, this is another like clarity thing. We'd call not frozen rather than comparing frozen with false. A couple of common errors that happen with using the Boolean operators and an or. It's surprisingly common to confuse which one you're supposed to be using, if we're meant to be using and or if we're meant to be using or. So a value lies between 0 and 100 if it is at least 0 and it is at most 100. A value lies outside of the range 0 to 100 if it is less than 0 or it is greater than 100. Unfortunately, there is no golden rule of when to use and an or. You just have to think carefully about what ranges you're looking at and what you're trying to do. This leads us on to kind of the second topic of this session, which is all about slicing up strings. So sometimes I only actually want to look at part of the string that someone's given me rather than the entire string. And this part of the string is called a substring. So for example, let's say we get a user to enter some monetary value, and they enter it with a pound sign. So maybe they say it's £1.99, but they say pound sign 1.99. I don't actually care about that pound sign. I actually only care about the 1.99. So I'm going to slice that string out, that substring out, that 1.99 out of my pound 1.99, and then do stuff with that substring. Maybe convert it to a float, and then maybe do some maths with it. Okay, so the idea is we're taking part of a string, not the whole string. Okay, so if S is a string, then we can take a slice using square brackets. So let's say S is the string some string. Then we can take a substring from S by having S square bracket, the index we're going from to the index we're going to, and then close square bracket. Okay, this is going to return a new string and store it in the value S2. The original string S is not changed, right? We're taking some of it or copying some of it. We're not like actually removing parts from the original string. The arguments from the slice operator are the first index to include. Remember that we're using indexing from 0. Okay, so that's our from value, followed by the first index we're going to exclude. So go up to this value, but not including it. And that goes in the to slot. Both of the parameters, from and to, are optional. And then the hint in the little yellow box is slices work with all sequences, so we could do this with lists as well, not just strings. I don't think we've really looked at lists, but slicing works on sequences of values. Okay, so here are some examples. If we have the string hello, and I'm going to slice out from the second index to, but not including the fourth index, I would return double L. Okay, so H is 0, E is 1, is in the 1 index. The first L is in the 2 position, the 2 index, and we're going up to the fourth index, but not including the fourth index. The fourth index is the O, so we're going up to there, but not including it, so we just take out the double L. If I were to go hello from 2 to 5, again, I'm starting at this L, and I'm going all the way up to the 5th index. Well, we don't have a 5th index. We can carry, because it's a string of length 5, but only from 0 to 4. But we go up to, but not including the 2 parameters. So we go up to the 5th index, which doesn't exist, but not including it. So we include the 4th index. Okay. Hello from 0 to 3, we start at the 0th position, which is H, and we go up to, but not including the 3rd position, which is the 2nd L. So we only get HEL out. Okay, if our string was hello, and we will go from 0 to the length of S, this is going to go from 0 to the length of S, which is length 5. So we go from 0 to 5, but we don't take the 5th index because it doesn't exist. We go up to, but not including it. So we actually take up to the 4th and including the 4th index, which is the O, and we'd actually get the full hello back. Okay, if I had hello, and then I went from 0 to the length of S minus 1, the length of S is 5, 5 minus 1 is 4, so I'm going from 0 up to, but not including, the 4th index. So 0 index, 1 index, 2 index, 3 index. I don't include the 4th index, and I just get hell. And then let's say our string again is hello. We're going from the first index up to, but not including position 5. So the position 1 index, well, this is position 0, so we're starting at position 1, and we're going up to position 5, but not including position 5, so we just get E-double-L-O. A couple more slicing examples. I can leave the to or the from to be blank, right? If I leave the to if I leave the from blank, sorry, it starts at the beginning. So it just starts at position 0. Okay, I haven't provided a from here. It's just going to start at position 0 and start from H and go up to, but not including the 4th index. So 0, 1, 2, 3. So it's going to return hell. If I leave out the to in part of the slice, it's going to go from whatever I give it as the to. From whatever I give it as the from to the end of the string. Okay, so it's going to go from position 1 to the end of the string. So position 0, position 1, and we're just going to get LO. Okay, so if you can read these result boxes, this returns the string hell. Take everything from the start, because we haven't provided a from, up to, but not including the 4th index. And then for the second one, return the string LO, start from position index 1, and take everything up to the end because we haven't provided a to as part of our slicing operator. So both the from and to parameters may actually be negative, in which case we can count from the end. So currently we've been counting from position 0 up to position 4. Now we can count backwards, starting from position 4 and counting backwards to position 0. So we're taking from the start, because we haven't provided a from value, up to -2. That -2 means up to the end, but not including the last 2 characters. Okay, so not including the 0, the O or the L, so these last 2 characters, which is going to return hell. Okay. Similarly, we could actually start from a negative value, and that means from the end, count backwards 4 characters, so 1, 2, 3, 4. So start from the E and go up to 2 characters back, not including the second character. So not including these 2 characters, so we actually only get EL back. Start 4 characters from the end, this is what this is telling us, and take everything up to, but not including, 2 characters from the end. That's what this is telling us. Okay, so you can use negative slicing or negative values when slicing out substrings. That can be quite helpful, depending on what your game uses to enter. So we looked at ands and ors, we looked at Boolean values, we looked at slicing substrings. We're going to look at input validation now. So accepting user input can be quite dangerous. If we consider the elevator program, this is probably, I think, from session 2, we can assume that the elevator panel has buttons labeled 1 through 20. Okay, and we're going to get the user to enter a value. The user can enter any value it wants, but we don't really want it to enter 13 because there's no 13th button because we're superstitious. And it seems a bit weird if they enter a value greater than 20 because we only have 20 floors, and they really shouldn't be able to enter a value less than 1. There's no -7th floor. Okay, maybe our building doesn't have like basements and things like that. Okay, so the following are going to be illegal inputs if the user inputs them. We don't want the user to be able to enter the number 13. So if the user enters the number 13, we're going to print out an error telling them there's no 13th floor. We don't want the user to enter 0 or a negative number, because our floors go from 1 to 20. And we don't want them to enter a number larger than 20, because it only goes up to 20, it doesn't go greater. So we're going to use an OR thing here to check, to make sure that the floor value is going to be between 0 and 20. So if it's less than or equal to 0, then we're going to print and say, hey, you can't enter a number 0 or less. And similarly, if the floor is greater than 20, we're going to print out, hey, you can't enter a number greater than 20. Okay, and then the other thing that we don't really want them to do is input a sequence that isn't digits, right? We only want them to enter things like 1, 2, 3, 7, 12, 15, whatever. We don't want them to enter things like 5, spelt F-I-V-E. Okay, that's going to be a problem. We can deal with this using something called an exception mechanism. We're not going to cover that until quite a bit later in the course, so don't really worry too much about dealing with people who don't enter digits when asked to. Okay, so this is our program. We get the user to enter a floor number, and we convert that string into an integer. We check if the integer value that they've entered is 13. If it is, we tell them, hey, there's no 13th floor. Otherwise, if the floor number is less than or equal to 0, so 0 or less, or the floor number is greater than 20, we print another error saying, hey, you have to enter a number between 1 and 20. There is no floor less than floor 1. There is no floor greater than floor 20. Assuming that those both are false, so they didn't enter 13 and they did enter a value between 0 and 20, we can now provide the actual value that we want to return. Okay, so if you were to copy down kind of this section of the program and then run it, if we entered something like floor 13, we should get the output of there is no 13th floor. Okay, so that's kind of the end of this session. There's a lot in there, and Boolean values can be quite confusing and quite difficult, so definitely spend some time going back through this and kind of trying to test out the Boolean values with maybe some real-world analogies that you can think of, and then go and try and do the problem tasks, because they should help with ifs and else statements and multiple branches. Otherwise, we will see you in the 6th session when you choose to watch that. Thank you.